Hello everyone, welcome back to my channel. In my previous lectures, I have discussed about JJ functions atomic model and Rutherford atomic model. I also have discussed some important points which are very important for class 11 students as well as for NEET and JEE applications. In this lecture, I am going to discuss about Max Planck quantum theory. This theory is very important to understand next atomic model, which is Niels Bohr's atomic model. Many numerical problems used to come from this theory, right? So, class 11 students as well as NEET and JEE should prepare this point very well. So, before discussing Max Planck's quantum theory, I would like to share some information about Max Planck. Max Planck was a German physicist. He introduced his quantum theory when classical mechanics of physics was unable to explain black body radiation. Now, see, I have used the word black body, right? So first, you should have a little information about what is black body. So, what is a black body? A black body actually it is an ideal concept, right? So black body means a substance. Suppose this is a substance and it is assume that a black body is a substance when electromagnetic radiation like IR, UV or visible radiation fall on this substance, the black body would completely absorb all the electromagnetic radiations which fall on this substance. So it is an ideal concept, and this concept says that if there is a substance which can absorb 100% of the electromagnetic radiation which fall on it and cannot reflect any part of the electromagnetic radiation which fall on it, or cannot transmit any part of the electromagnetic radiation which fall on it. So this is completely an ideal concept. There is no substance in nature which is completely black body, right? So we can give some examples, right? So this is the concept of black body. Now, what is black body radiation? When a black body is heated, all the electromagnetic radiation like IR, UV, or visible radiation would emit from the black body, whether it is IR, UV, or visible. That means all of the electromagnetic radiation would emit from the black body if it is heated, right? So this kind of emission of electromagnetic radiation from the black body when it is heated is called black body radiation. The radiation of the black body does not depend on the matter of which the black body is consisted of. Right? The black body radiation is only dependent on the temperature. That means when the temperature, the heating temperature of the black body is increased, the intensity of the black body radiation increased. When the temperature decreased, black body radiation would decrease. Right? Suppose when temperature is less, ion come out from the black body. When temperature is in middle range, some red light would come out from the black body. If temperature is increased more, then blue light or greenish blue light would be observed from the black body. That means the amount of the radiation or the intensity of the radiation of the black body only depends on the temperature of heat. Right? So you have understood what is black body and what is black body radiation. Right? So now you all have observed that when sun rises, light is faded throughout the hour, right? Or whenever you leave a light, that light fades throughout. Classical mechanics of physics explains that this fading of light is continuous, right? But Max Planck, in his quantum theory, explains that whenever any energy comes from a source, if I take light as an example, then if light is coming from this source, according to Max Planck, this energy which is coming out from the source would come in a discrete manner. That means the light energy or any kind of energy is consisted of small units like this way, and this small unit is called quantum. This small unit is called quantum. If the energy is light, then quantum is actually photon. So Max Planck, in his quantum theory, describes that any kind of energy, whether it is light energy or other energy, is consisted of small units, and that small unit is named as quantum. In case of light, it is photon. Right? That means according to Max Planck, any energy is consists of small packet of energy, small unit energy, and that small unit energy is called quantum. Like whenever a building is made, That building is made by adding little brick, right? So whenever staircase is made, that staircase is made by adding step into, right? Like that. Max Planck in his activity explains that any kind of energy is made of made up of small unique energy, and that small unique energy is be named as quantum. In case of light, it is photon. So he also explains that whenever any energy comes from a source, it is flow, then that emission of that energy would be discrete, as the energy is made up of small units. So the emission of the energy would be discrete, not continuous. Like the discrete emission, like the emission of the energy which is discrete, whenever energy, if it is light, falls on a surface of substance. If it is a surface, and that energy which is coming from a source would come and fall on the surface of this substance, the absorption of that energy or light. In case of this example, I have taken light. So the light would come and would be absorbed by this surface, not in continuous manner, but in discrete manner. Means one packet of energy would be absorbed first, then next packet of energy would be absorbed, then next packet of energy would be absorbed, right? So the absorption of energy on any surface, on any substance, or the emission of energy from any source would be in discrete manner, not in continuous manner, right? So this is the concept which we received from Max Planck quantum, and he gave the amount of energy which is consistent within a quantum. That means a quantum contains a specific amount of energy which is E, and that specific amount of energy is directly proportional to the frequency of the energy, right? So E is equal to h nu, where h is the Planck constant, and it has value of 6.623 into 10 to the power minus 34 in second. That means Max Planck quantified energy. He actually gave a unit of energy which has a specific amount of energy which is h nu. In this way, Max Planck quantifies energy. This is why this concept, where energy is quantized, is called quantization of energy, right? So this is the quantization of energy which we got from Max Planck quantum theory, right? And if a whole radiation has n number of quanta, then the whole of the radiation has energy n is equal to n into h nu. H nu is the energy of each quantum, as n number of quantum is there. So if n is equal to 1, that means that whole radiation has only one quantum, then energy of that radiation is equal to E1, that means 1 into h nu. If n is equal to 2, then E2 is equal to 2 into h nu. If n is equal to 3, that means number of quantum is equal to 3, then E3 is equal to 3 into h nu. Right? So, if any kind of energy has quantum number is equal to 10, then E10 is equal to 10 into h nu. This would be the energy of the whole of the radiation. Right? So, actually, Max Planck in his theory quantify the energy and give a specific amount of energy to the quantum from which we can calculate whole of the energy of the radiation like this, right? So Max Planck's quantum theory has some advantage. Max Planck's, Max Planck's quantum theory paved the way to the modern quantum mechanics. And based on this quantum theory, later Niels Bohr proposed his atomic model. Albert Einstein used this concept of Max Planck quantum theory to explain his photoelectric effect. Atomic spectra could be explained properly from Max Planck quantum theory. Right? So these are all the advantages of Max Planck quantum theory, though it has some limitations. Max Planck quantum theory could only explain the black body radiation, but it could not explain atomic, atomic structure. It could not explain the feature of electron. So this is how Max Planck, by giving this quantum theory, paved the way of modern quantum theory or quantum mechanics. Right? So this is all about Max Planck quantum theory. This theory is very important for class 11 students as well as for me and JEE. The point which are very important to remember, those that used to come in exam are the equations actually. That means E is equal to h nu, where we can calculate the energy of a quantum, and E is equal to nh nu. From this equation, we can calculate the energy of whole of the radiation, and mu is equal to c by lambda. Mu means frequency of the radiation or the energy. C means velocity of light, and lambda means wavelength of radiation. And energy E is equal to h into c by lambda. These four equations are very important. You should remember these four equations. So from Max Planck's quantum theory, you should remember these four equations. Either you should come in exam, because many limited problems used to come from these equations. So you should prepare well and always try to remember these equations. And I hope this lecture has been very easy for all of you. And I have tried to make it very easy so that you can understand visually. See, if you have any doubt, please mention that in my comment box. And if you need PDF note, a link is there in my description box. Click that. It will direct you to my Google Drive. You have access to my Google Drive. All the PDF notes of my lectures are there. You can download them and prepare them. Prepare well and do good reading. Thank you so much for